Hey everyone, welcome to the factoring and square root quiz review. I'll be going over every question step by step to prepare you for the quiz tomorrow. So let's look at part one. We're just going to use the graphs and answer the question. So given the graph of f of x below, for what values of x does f of x equal 5? So here, we know that f of x is just going to be your y. So it's just asking at what values of x does y equal 5? So we know that y equals 5 is this line over here. So let's look at what x values intersect with that line. We see that x equals 2 and x equals -4. Okay, same thing here. Given the graph of g of x below, this is just our y. For what values of x does g of x equal -8? So again, we look at when y is -8. And what values of x intersects? So we see that x equals -1. And x equals -7. Okay, so we know that in both 1 and 2, there are two solutions for x. Here, let's look at number 3. Given the graph of h of x below, for what values of x does y or h of x equal -4? So if we looked at y equals -4 here, we see that there are no x values that intersect with this y equals -4. So there is no solution here. Okay, and at this point, there are 0 solutions. Okay, next we look at number 4. And it says, given the graph of j of x below, this is also just y, for what values of x does y equal 4? If we look at y equals 4 here, we see that there's one solution at x equals -1. So here we can see that at a maximum, all quadratic equations can have two values. So in 1 and 2, there are two solutions. But in 3 and 4, you can also get 0 solutions, as we see in 3, and you can also have 1. Let's look at part number 2. And these two questions are just reasoning questions based on what we know. So, true or false? When solving a quadratic equation, you will always get two solutions. Here, we can look at problem number 1. When we looked at 1 and 2, we saw that there were two solutions. For when y equals 5, these two x values. We also saw two solutions in number 2 when y equaled -8. But then here in problems number 3 and 4, we saw that 3 had no solutions. There were no x values that gave y equals -4. And there was only one x value for when y equaled 4 in number 4. So here, when solving quadratic equations, we won't always get two solutions. This is false. We can get a maximum of two solutions. This means we can have two solutions, we can have one solution, and we can also have 0 solutions. Okay, number 2 asks us, when Aldrich is solving a quadratic equation by factoring, he gets the equation 2x plus 1 times x plus 5 is equal to 0. So let's explain why you can set each of the factors equal to 0 and solve them separately, like I'm doing right now. The reason why is what we call the zero product rule. So we see that both of these factors are being multiplied together to get 0. We know that if the product of two things, let's say A and B, are equal to 0, then A has to be equal to 0, or B has to equal to 0, or both. This is why we can set each of the equations set to 0, each of the factors equal to 0, and then solve. Because either this could be 0, because 0 times x plus 5 will give us 0, and then 2x plus 1 times 0 will also give us 0. Part 3 asks you to solve each quadratic equation using the appropriate method. We're solving for every value of x, and if necessary, we need to round our answers to 3 decimal places. So the first thing we want to do, I'm just going to make a note here, is think about all the methods we used to solve each quadratic equation. So the first method that we learned about was the square root method. So we took the positive and negative square roots. That was when we realized that there was one x term. And that was something squared. However, we realized that once there's two x terms, so like if there was an x squared and there's also an x, we can't use the square root method because you can't square root the x. So what instead we have to do is use the factoring method. So that was when we took factors and we set them equal to 0. So let's take a look at problem number 1. Before we even start, we need to look at what method we're going to be using to solve this equation. So the first thing we want to do is check how many x terms there are. So since there's one x term with that squared, we know that we're going to be using the square root method. So to proceed with the square root method, what we're going to be doing is trying to get this x alone. But first, let's try to get the squared alone. So what we're going to do is move everything to the right-hand side. So in this case, we do that by adding 32 to both sides. Then from there, we're left with 2 times 3x plus 9 squared is equal to 72. From there, we cannot square root yet. We still have this 2 right here. In order to get rid of that 2, we're going to have to divide it. Then we're left with 3x plus 9 squared gives you 36. From there, we know now that we can square root each side. Remember that when we're taking the square root now, we have to look for both the positive and negative root. So now we're left with that 3x plus 9 is going to be positive negative 6. So this is where we split up our solutions. We know that 3x plus 9 has to equal to positive 6, but 3x plus 9 also has to equal to negative 6. From there, we solve just like we would for x. So to do that, we have to subtract 9 from both sides first. In this left-hand side, we have 3x is equal to negative 3, and now we have that x is equal to negative 1. Here, we subtract 9 from both sides again, but now we're left with 3x is equal to negative 15. From there, we can divide 3 from both sides, and we get that x is equal to negative 5. Note that just by taking the negative 1, we can't just make it positive. So our solutions aren't negative 1 and 1. Our solutions are negative 1 and negative 5. This comes from making the root positive and negative. Okay, now let's look at problem number 2. First, we need to look at what method we're going to be used to solve this equation. We know now that compared to number 1, we realize that there's two x terms here. We have x squared and the 3x that we can't just combine. So instead, now we're going to have to factor. So in order to factor, we need to make sure our equation is set to 0. Right now, our equation is not set to 0. In order to do that, we're going to have to bring everything from the right-hand side over to the left-hand side. We do that by subtracting it from both sides. So in this case, we have to subtract 2x from both sides. And we also have to subtract 5 from both sides. Then we're left with x squared. And then 3x minus 2x gives us positive 1x. And negative 35 minus 5 gives us negative 42. Now our equation is set to 0. From there, we look at what a, b, and c is. And a, b, and c are the numbers in order. So we have that a is equal to 1, b is equal to 1, and c is equal to negative 42. We know that a and b are 1 because the implied number on these x values are 1. Okay? Then we multiply a and c together. We get that a times c equals negative 42. So our job is now to find a number that multiplies to negative 42 and adds to b, which is 1. We get that from here. So now I'm trying to think of two numbers that multiply to negative 42 and add to 1, because what we're multiplying is negative and what we're adding to is positive. We know that at least one of the numbers is going to be negative. In addition, because what we're adding to is positive, the smaller one has to be the negative one. So some factors of 42 are 6 and 7. But 6 has to be negative in order for negative 6 and 7 to add to 1. So from there, we've gotten our magic numbers. So what we're going to do is we know that it's in factored form here. Because we know that it's in factored form, we put our magic numbers to the right side of the factor. Now we also have to count for this x squared right here. To split that up, that becomes really easy. The only factors of x squared are x and x. So now we're done. Our factors are x minus 6 times x plus 7. Now, I said we're done, but we're not done just yet. We're done with the factoring part. So now we have to just set each factor equal to 0 and then solve for x from there. So we add 6 to both sides here to get x is equal to 6. We subtract 7 for both sides to get x equals negative 7. Now we have two solutions here. Okay, now let's look at number 3. We have that 2x squared minus 11x plus 5 is equal to 0. First, we need to figure out what method we're going to use here. Because we have those two x terms again, x squared and x, and we can't combine them, we have to solve by factoring. So again, we do the same steps. First, is the equation set to 0? Lucky for us, it is. Then let's identify a, b, and c. We have that a is equal to 2, b is equal to negative 11, and c is equal to 5. Next thing we want to do is multiply a times c. We have that a times c is equal to 10. We know that we need to find two numbers that multiply to 10 and add to b, which is negative 11. Okay, from there, because what we're multiplying to is positive, and what we're adding to is negative, we know that both numbers are going to be negative. So some factors are 2 and 5, but we know that -1 and -10 are going to give us the right numbers. So -1 times -10 gives us +10 when we multiply them, and then -1 plus -10 gives us -11. So again, using our magic numbers, we know that it's going to be in factored form like this. From there, we just add in our magic numbers, -1 and -10. Unlike number 2, though, we do have a number in front of this x squared. We see that there's a 2. We need to distribute this on the left side of the factors here. We know that x distributes like this. We know that there's going to be x's in both. But we don't know where the 2 is going to go. It could go over here, or it could go over here. So in this case, we're going to put 2 in both, assuming that what we're writing right now is wrong. We know that the last two numbers here have to divide to right now they multiply to -10, but we know, sorry, they don't multiply to -10. They multiply to 10, but we know that they have to multiply to 5. So to get to 5, we know that we have to divide 2. So at some point, we're going to have to divide out 2. We also know that we have to divide out 2 because we added in an extra 2 here. So one of these two doesn't belong, so we're going to have to divide out of 2. Let's look at where we can divide out of 2. 2x minus 1, we cannot divide out of 2. But 2x minus 10, we can divide out this 2. So we leave 2x minus 1 as is, but we know when we divide 2x by 2, we get x. -10 divided by 2 is -5. So now we're done. Like I said, we're only done with the factoring part, so now we have to solve for x, which is really easy. We set each factor equal to 0, and then we solve for x independently. So in this case, on the left-hand side, we add 1 to both sides. We get that 2x is equal to 1. And then we get x is equal to 1/2. In order to get x alone here, we add 5 to both sides, and we get that x is equal to 5. Okay. Now let's look at problem number 4. We have that 7 minus 3x squared is equal to -14. The first thing we want to do is figure out what kind of method we need to use to solve this equation. Because we see that there is only one x value here, we're going to have to solve using the square root method. In order to, again, like number 1, solve for the square root method, we need to get that x squared on its own. To do that right now, we have to subtract 7 from both sides. So we get that -3x squared, once the 7's cancel out, gives us -21. Again, now we have to get x squared alone. So first thing before we square root is we have to divide the -3. If it helps you to make the do-undo chart, I would make it so you know you're going in the right order. So then we're canceling out the -3 here. We get that x squared is equal to 7. And now what's left to get x alone is we have to take the square root. Remember, when we're taking the square root, we have to take the positive and negative square root. So we're left that x is equal to positive negative square root of 7. So we have that x is equal to positive square root of 7 we have that x is equal to negative square root of 7. You can leave it like this, or you can plug it into your calculator and round your answer to 3 decimal places. So part 4 is actually just practicing a skill we need when we're solving by factoring. All of the problems when we're solving a quadratic equation by factoring asks us to reason through and make sense of what two numbers multiply to something and add to something. So let's look at part number 1. What two numbers multiply to 14 and add to 9? So the first thing to make it easier on yourself is to look at factors of 14. So we have 1 and 14, 2, 7, and right now, I think that's it. We need to figure out what, when added, will give you 9. We can see it pretty clear here that 2 and 7 will add to 9. We also know that both of these numbers are going to be positive because what we're multiplying to is positive and what we're adding to is positive. Okay, now let's look here. What two numbers multiply to 30 and add to negative 11? So in this case, we're multiplying to something that's positive and adding to something that's negative. We know then that both numbers have to be negative. So let's look at some factors of 30. We have 1, 30, or negative 1 and negative 30, sorry, because we know that both have to be negative. Negative 2, negative 15, negative 3, negative 10, negative 5, negative 6. Whoop. And we see that negative 5 plus negative 6 will give us negative 11. So our numbers are negative 5 and negative 6. Okay. Part number 3 asks us what two numbers multiply to negative 6 and add to negative 5. So we see here that what we're multiplying to is negative and what we're adding to is also negative. In this case, one number has to be negative, and because it's adding to something that's negative, the bigger one has to be the negative. Okay, so let's look at some factors of negative 6. We have 2 and 3, and we know that 3 would have to be negative for the whole thing to be for it to be negative when we add. We have 1, negative 6. We realize that 1 and negative 6, when added, will give us negative 5. So our two numbers are 1 and negative 6. If we look at 4, what two numbers multiply to negative 36 and add to 5? So in this case, we're multiplying to something that's negative and adding to something that's positive. So again, like number 3, we know that one number has to be negative, but because we're adding to something that's positive, the smaller one, or the smaller number, has to be negative. Let's start by just looking at some factors of negative 36. We have negative 1, 36, negative 2, 18, negative 3 and 12, negative 4 and 9. Here it is. When we add negative 4 and 9, we get positive 5. So our numbers are negative 4 and positive 9. Okay, part 5 asks us to use this graph to answer the following questions. First of all, we see that this is a quadratic function that's being graphed. And the shape of this quadratic function is what we call a parabola. We know that it's quadratic because at any point we can have a maximum of 2 solutions here. So let's look at the first question. When f of x is equal to 4, so we know that f of x we can also call as y. When y is equal to 4, how many solutions are there for x? So we see that there's 1 where the graph intersects with this line, and there's also 2. So there are 2 solutions. More specifically, when y is equal to 2, it asks us what values of x show that y equals 2. So we look here, we have that x is equal to 2, and we have that x is equal to 6. In this case, there are 2 solutions. Now let's look at a value for y that will only have 1 solution for x. Unlike when we're looking for 2 solutions, where there could be multiple y values that do that, we know that there is going to be only 1 value that has 1 solution, and it's this point right here. It's always what we call the vertex. So the vertex is at y equals -2. So if we drew a line at y equals -2, we see that it only crosses that line once. Now we have to look for a value of y that has no real solutions. So what that means is we have to look for a value of y that the graph never crosses. In this case, the graph actually just never crosses underneath this vertex here. So an answer that we could have written is here y equals -3. We see that the graph will never touch y equals -3. Okay, what type of function is graphed to the left? Like we said, it is a quadratic function. We know that because it's in the shape of a parabola, and we can have a maximum of 2 solutions. So when we're looking at the domain and range of of our function, our domain asks us for our x values. So we're looking from the leftmost point all the way to the rightmost point. We know that the graph can keep going on forever and ever. So our domain is -infinity to infinity. Remember that just because there's no point here, we know that it's going to keep going on forever and ever. Our range is a little bit different. We know that there's no y values past y equals -2 here. Right here. So our range actually goes from -2 right here all the way up to infinity. So quadratic functions with the domain will always have a domain of -infinity to infinity. Our range will be from our lowest y value, which is going to be at our vertex, to infinity.